So, explain what homozygous and heterozygous traits are. You all can use your Chromebooks, list and explain, or not list, sorry. Research and list 3 examples of dominant traits and 3 examples of recessive traits. How many of you all still need to take your vocabulary test from yesterday?
The one with like 16 points.
The one with 16 points. You feel ready to take it? It's over the first day. Okay, so just take it by Friday. So, if you have not taken it, you have until Friday to do so. Do not forget Friday is also your second 8 vocabulary words. So, first 8 was this Friday, second 8, next Friday.
What's today?
Today is Tuesday. Questions about that?
Do we do both?
No, I don't think so.
No, we had veterans.
Number 2, Thanksgiving break is in 8 days. Woohoo! Yay!
No, I don't have time for Thanksgiving break.
You don't have time for Thanksgiving break?
No.
Sorry.
Huh? In like 8 school days?
8 days. So not counting today, you'll have 8 days left.
School day?
8 school days, yes. 8 school days. So I am going to give y'all 5 minutes. Get your bell work down. Okay. Oh, sorry. Excellent. If you have to ask me if it's good enough, does that mean? So, today, we are finally going to be starting Punnett squares. Yay. Yay. We are going to be putting together everything that we have learned the last week-ish all into one. So we'll be slapping it all together.
Like a
cheeseburger.
Like a sandwich.
Like a sandwich, yeah.
Yeah.
We'll slap it all together like a sandwich.
Yeah, agreed.
Is there anybody that is physically not here? Not, that isn't in leadership?
I'm not emotionally.
Everyone has some notice here. Except for Kimberly, but she's not in.
So, with that being said, also on the topic of your vocabulary quiz, I will be letting anyone do retakes on this for the first part. However, if you want to do retakes, you still have to write each definition 10 times in order to get the retake. If you failed this, which means you got an 8 or lower, you are required to do it. It is not optional. You will be doing it. Questions, comments, concerns about that? I don't know. I haven't put y'all over here.
I'm serious, I don't want to do it.
If you were in here yesterday, then you did.
Oh, yeah, I did.
Should I hear talking? So is Lena actually here?
Lena is here.
Yeah.
Okay, Lena's here. Leadership. So everybody's here, right?
Yeah.
Yay.
One.
Typically, we have like 4 to 6.
Okay, I'm gonna give y'all 2 minutes to wrap it up. Does anybody need you say you're good? Think so? Okay.
This is more.
45 seconds. Everybody feel calm and sleep.
Calm.
Feel pretty sleepy. Sleepy has a calm. A lot better than last week. I don't got a lot of there to us. Somebody took one of my dinner. Happy birthday, Colin!
Happy birthday.
When the timer goes off, yes.
Okay.
Can I know it's Colin's birthday?
We'll go sing happy birthday to Colin. Okay, so real quick, we will sing happy birthday to Colin and then we will go over Miller, okay?
Okay.
One, Frank, you gonna start us?
Yeah, sure.
Happy birthday to you. Happy birthday to you. Happy birthday, dear Colin. Happy birthday to you.
How old are you? Yeah! Okay, yes, now you can ask a question.
I put the right stuff.
Colin, how old are you?
Oh, maybe it's
We'll talk about it. Okay, so, what does it mean if something is homozygous?
It's a sign.
two of the same.
A boo.
It's the same.
What's the same?
Like
Two alleles for.
Two alleles are the
like BB.
same. Can they be uppercase and lowercase?
No.
It's not the same.
Can they both be uppercase?
Yes.
Can they both be lowercase?
Yeah.
Yes.
What does it mean if they are heterozygous? Right.
Well, the different alleles in a gene. So like,
Different alleles. Give me an example.
like big X and little X.
Big X, little x. Everybody give it that?
Yeah.
Okay, what are some examples of dominant traits that you all found? Brown eyes, freckles,
Right-handed.
right-handedness,
People.
dimples.
Hey, get out there. Get out.
One more dominant trait.
I thought it was three.
You all write three, I'm asking. Webbed fingers. Does anybody know what it means if your fingers are webbed?
Like there's,
They're wet,
like
like
there's
wrong.
skin in between.
There's
I was
skin
looking
in
up too
between
much
them,
that.
yes, little wells.
So the high definition of web fingers is excess skin going.
Excess, not access, excess.
Excess skin
Excess
going
is-
between your
Hey,
fingers.
I have web fingers.
So, what are some recessive traits that you all found? Jalen, what's one?
O-type blood.
O-type blood. Blue eyes.
Okay.
Oh.
Being tall.
Red hair.
Red hair. One more.
A straight hairline.
Short. Straight hairline. So what's the opposite of a straight hairline?
A V shape.
A widow's, it's called a widow's peak.
Yeah,
Widow's
recessed
hair.
hairline.
That's recessive. Huh?
A recessed hairline.
Yes.
Receding.
Receding hairline. I knew what you were talking about. Okay, so,
Wow.
Abu, what's yours?
It was something like, it was like
Okay,
Good feeling.
so, real quick, what we are going to do before we go into Punnett squares, we're going to have us a little movement in here today.
A movement.
Oh, wait.
Are we gonna do jumping jacks? I can't. do
No,
that.
so, as a class, you all are going to come up with 2 little dance moves. Okay? Now, they do not have to be complex, they can be as simple as whatever he's
We're
doing.
done. We're done.
That could be one, it could be a shimmy, it can be like the chicken dance type thing. Whatever you want to do. As a class, you all are going to decide have two dance moves.
One of them's gonna be my friend. Right.
One is going to represent homozygous, the other one is going to represent heterozygous. I'm going to give you 60 seconds to talk as a class and come up with them. Go.
Macarena, guys. Macarena, okay? That's what we're gonna do. One of them's gonna be Macarena. Decided? 1, 2, 3, sold.
No, what we should do a dance move, including Lane. We just throw Lane up and just throw him out.
Yeah, we picked Lane out, you know, we can all do that.
Willing crowds.
So one's gonna be Macarena, if you'll decide it might be all nice.
Yeah.
So what do we do? What do we do if it goes over Harrison and Jake at the same time?
Let's just let Harrison do it.
Wait, did you just moonwalk? Moonwalk.
Okay, have you all come up with your two dance moves?
Macarena
Okay,
and.
hurry, come on.
Harrison has it.
How do we? Well, Harrison knows.
Are you voluntarily Harrison to come up with one? Now, everybody has to do them. So this is, everybody has to do it.
Harrison, make it easy.
What shows homo, what shows? Harrison has to be homo.
So, one
Hey,
homo,
what
one
if we
hetero.
make
Come on, let's go, quick.
What if we all make like a big B or something like that?
No.
Like a little B.
No. Dance
Wait,
That's homo, okay.
the Macarena will be hetero.
Does everybody know the Macarena?
Yep, uh-huh.
I do not do the Macarena.
Okay, everybody stand up. So first one, oh my goodness. If the traits that I wrote on the board, if it is homozygous, what are you all going to do?
Right.
Everybody do it. Everybody's got to do it. Everybody's got to do it. If it is heterozygous,
The Macarena.
okay. I'm gonna put on a little song for you.
Oh, watch this transition. Watch this transition.
Any song suggestions?
Show, man.
The Banana Man by Charlie Brown.
Hey, you should make the Macarena.
So when I write the phenotype on the board, you all are going to see the answer. Okay?
Okay.
I forgot which one that was.
Which one's hetero again? Which one's homo?
Which one's hetero? Which one's homo?
Hetero is what? Boils. Hetero? Hetero is Macarena.
Why are we all just jumping? Ellie in the best at
Oh, sorry. Oh, yeah, this is great.
Heterozygous.
I've never done it before.
Big D, little D. Big D, little D. Oh, okay. Big X, big X.
The first time you're
Okay, we all can have a seat. Wait, no, let's do it quick one more time. So, we have talked, get y'all awake this morning.
Yep, you did.
Hopefully you all gonna have lots of big fancy questions for me now, right?
Yeah.
Okay, so remember when I told you genetics is going to get very complicated very quickly, right?
Yep. Yes.
Okay, this is where we're starting to put everything all together.
So, I have a confession to make. For my classroom, I always wanted a hairless guinea pig. They sell them at some pet stores, but they can be really hard to find. And while I I doubt they do so well in the wild, their genetics are fascinating. And so are guinea pigs. We spent quite some time on LOL cats, but we'd spend even more time if someone would make a funny guinea pig site. Most guinea pigs have hair. This is because of their DNA. DNA makes up genes, and the guinea pigs received genes from both their mother and their father. An allele is a form of a gene, and often represented by a letter. In this case, we'll use the letter H for hair. A hairless guinea pig has two recessive alleles for the trait of having or not having hair. A recessive allele is usually represented by a lowercase letter, or allele. By recessive, it means that the allele will not usually show up. The only way it will show up is if there is no dominant allele present. A dominant allele is represented by a capital letter, and it's an allele that will show up. Think of it as dominating. So a hairless guinea pig does not have a dominant allele for hair, and that's why the recessive trait, not having hair, shows up. A hairless guinea pig's genotype, that's the genetic makeup of an organism, can be represented as a lowercase little h. A guinea pig that does have hair can be represented as a big H, or a big H, little h. See, it only takes one dominant allele, a capital H, for a trait to show up. That dominating allele means that the recessive allele is hidden. Now, we're not quite done with the vocab here. A genotype of big H, or little h, is considered homozygous. The root in this word means same, and they are the same case. Big H, those are both capital letters, and little h, those are both lowercase letters. So big H is called homozygous dominant because of the capitals, and little h is homozygous recessive because of the lowercase.
Everybody
The
gets that,
genotype
right?
of big H, little h is considered heterozygous. The root in this word means different because their letters are different cases. One is a capital and one is a lowercase. If I were to show you a guinea pig with hair, would you know its genotype? Well, you would know it's not little h, because if it was little h, then it would be hairless. But remember, a guinea pig with hair, it could be big H, or big H, little h. We don't really know. We could do a test cross to eventually determine this, but you can't tell just by looking at the guinea pig. Now, if we had a hairless guinea pig, we do know for sure that it's little h, because if it did have a capital letter, even one, that dominating allele would take over and it would have hair. So let's try a monohybrid cross. The root mono means one because it focuses on one trait, in this case, hair. And that means a Punnett square would need to be created like this with 4 squares. In our cross, we are going to cross 2 heterozygous guinea pigs. So let's look at this in steps. Step 1, first, figure out the genotypes of the parents. Heterozygous means big H, little h. Step 2, place one parent along the top of the Punnett square, outside of the boxes like this, and place the other parent along the left side of the square, outside of the boxes like this. Step 3, cross them. For formatting purposes, we always put the capital letter first. The results that you get in the squares would be the offspring, the babies. Now, if I were to ask you the genotypes of the babies, you could list them out. 1 big H, 2 big H, and 1 little h. I could even turn that into a genotype ratio of 1 homozygous dominant to 2 heterozygous to 1 homozygous recessive. Or a percentage. 25% are homozygous dominant, 50% are heterozygous, and 25% are homozygous recessive. Well, what if I asked about the phenotypes? What does that mean? I like to think that pheno sounds like physical. So the phenotype would be the physical traits of that organism. And in this example, it's whether they have hair or not. Now remember, any babies that have a capital H have a dominating allele, and they will have hair. So the babies that are big H, or big H, little h, they have hair. So 3 of them here The one big H baby and the two big H little H babies, they all have hair. The homozygous recessive baby, which was little h, that baby has no dominant allele present. So this little guy would be hairless. So you could say the phenotype ratio is 3 have hair to 1 that's hairless.
So, you all remember talking about probability and stuff last year, right? Okay, if you asked when are we going to use this, now is the time that you all are actually going to use this. So, today we are talking about Punnett squares. Everything that has gotten pounded into your little minds over the last 2 weeks is starting to come to life here. So, Punnett squares should be familiar. It was one of your vocabulary words on your test yesterday, correct?
Yeah.
Oh yeah, that's the one I asked you. I was like, you have not been over this.
Yes. So, a Punnett square is what we call, it is a diagram that we use to predict the probability of the genotype and phenotype of an offspring giving two parents. Okay, so we use Punnett squares to predict what the genotype and phenotype of two different parents are going to be, or the offspring of two different parents. It is going to be expressed as a percentage. For the sake of keeping things simple, we are only going to use these basic Punnett squares. So 4. You already have 4 squares. If you've got 4 squares, each square is going to represent what percent?
25.
25%, right? 4 quarters in a dollar. Each square is going to be worth 25%. So we use the genotype to predict the genotype and phenotype of offspring. So remember, when we say genotype, what am I going to be talking about?
The genetic makeup,
Genetic makeup, and that is represented by what?
letters.
Letters.
X,
Letters. If I say phenotype, what am I talking about?
physical traits.
Physical traits, what you actually see. Yes, Brady.
So you said that we were going to be using the Punnett square with 4 little squares, so they're bigger ones? Like really big ones?
Yes. So each little square is for 25%. It is possible, once you get to more complex traits, you can have Punnett squares that are 12 squares big.
Wait a minute, I've seen this before. It's like, when I went to DNA testing, and I had like 16 different squares.
Yeah, so there are complex traits that are bigger squares, but for the sake of keeping things easy and simple for now, we are going to start off with just 4 squares. Okay? They're very confusing to look at.
So this like one would be like 2%, and one would be, and the next one would be like 2.5%, and the next one.
So, if I go too fast at any point today, tell me to slow it down. I would much rather we go slow and you all actually understand versus rushing through it and you all being completely lost. Okay? So if I'm going too fast or if there's something that you all don't understand, raise your hand. I get very excited whenever talking about this. Like I said, when I majored in college, my original major was cellular and molecular genetics. So this is something I get very excited about, and when I get excited, I do tend to speak a little faster and try to move a little quicker. So if I'm going too fast, just raise your hands. 9 times out of 10, you are not the only one who is going to be making this alphabet needs to slow it down. You go about another 30 seconds. What little wells? Answers to what? There's no answers, there's no question. So, we good? Tammy, are you good? Okay, so, this is a color-coded example of what you all are going to be doing. So, the father's genotype is big A, big A. Is that homozygous or heterozygous? Homozygous. Is it dominant or recessive?
Dominant.
Dominant. So it is a homozygous dominant genotype, right? The mother, what kind of genotype does she have? Abu? Homozygous recessive. So she is homozygous recessive. When you are making your Punnett square, one parent's genotype is going to go on the top, the other parent's genotype is going to go on the side. It does not matter which one goes on the top and which one goes on the side. Okay, that does not matter. But what you cannot do is you cannot take one allele from the mom and one allele from the dad. So you cannot have big A here, little a here, big A here, little a here. Father's genotype on one side, mother's genotype on the other. Okay? Then what you are going to do is this big A that's sitting up here, it owns these two boxes. Okay? So it gets to dominate and come through in these two boxes. Same thing with this A. He owns these two boxes. He's sitting over top of them, these two are his. So he can drop down and take these. Does that make sense? This little A lines up with these two boxes. Therefore it gets to do what? It gets to hop in here. Same thing with this A. Since he's in line with these two boxes, he gets to slide in through here. Okay? This is all of the different, so you've got your parent genotypes here. The 4 boxes contain the possible genotypes of your offspring. So in this case, the offspring has a 100% chance of being heterozygous and showing the blue dominant trait, right? Does that make sense? So here's a real life example. We've talked about eyes quite a bit in here. This is what I will be expecting you all to do in about 10 minutes. Yes, little Wells.
My eyes are a little bit old.
Do you have blue eyes?
Yeah.
Mhm.
Wow.
So, in this case, one parent was heterozygous, the other parent was what?
Heterozygous.
Heterozygous. You've got 2 different alleles.
Oh, that's my parents.
Okay? So, both parents are heterozygous. This B owns these 2 boxes, right? So he slides down through here. This little blue B owns these 2 boxes. So he did what? Slid on down through here. This B owns these 2, so he hopped in here. Same thing with this little B. He hopped in these 2. That gives you 3 different possible genotypes, right? So there's a 25% chance that that offspring could have homozygous dominant brown eyes. There's a 25% chance that this offspring could have homozygous recessive blue eyes.
So I'm rare.
You're 25, you had a 25% chance, yes. 25% chance of blue eyes, what you had, and you came out. Yes, Colin?
Now, what if each parent has different eye color in the child?
So, if each parent has different eye colors than the child, so what you were saying is, so like this one, this parent has one dominant trait for brown, so what color eyes is it gonna have? Brown eyes. This one has a dominant B, so what color eyes is it gonna have? Brown. And the offspring could have blue eyes. Are you talking about that kind of situation?
No,
Okay.
So my
So
mom
one
has
parent has
brown
brown
eyes,
eyes.
my dad has.
Hold on, let Colin finish his question.
like, my dad has green eyes, and my mom has this bluish green.
Mm-hmm.
And all three, meaning all my siblings combined? Like, how did that come about?
Depends on which traits they carry. So you're getting into those, remember we talked about how you have those 16 section Punnett squares, that's what you're getting into. So we're gonna keep her simple. So everybody, yes, okay.
So, how do my eyes change color? Because I have green eyes and.
We'll get into that later. Right now, we're just worried about how you make a Punnett square, okay? So, to create a Punnett square, the black is what you need to have. The light blue, you don't necessarily need to have. Okay, it's just extra information. I will be posting these on Google Classroom at the end of class today, so if you just want to write the black, that is perfectly okay. You will have access to the blue at the end of class. Okay? So, first off, you're gonna draw a box with 4 squares. So, you've got your pretty little box. Wait. Huh? Wherever you're doing your Punnett square.
Okay.
Right now, we're just talking about how you make a Punnett square. So, one box, split that box into 4 sections. What trait do you all want to use? So, what trait do we want to use?
Hair color.
Hair color? Okay. What color hair do you want to use?
Brown.
Brown and blonde. We're going to say brown is the dominant. So it's going to be what kind of letter?
Capital.
Capital. We're going to say little b's blonde, so it's going to be
Lowercase.
lowercase. So big B's brown, little b is blonde. What kind of phenotype or genotype do you all want parent 1 to have? Parent 1 is going to be big B, little b.
Yeah. And I, what my parents do, little bit.
Parent 2 is little b, little b.
Yeah.
So, parent 2, parent 1, we're going to put at the top. You've got big B, little b. Parent 2, we're going to go down here, little b, little b. Everybody good with that so far?
Yeah,
Okay? Now you're going to fill in your boxes for your genotype. So, this big B, is it going to go here?
Yeah.
Is it going to go here?
Yes.
Is this B going to be in this box?
No.
No. Is this B going to be in this box?
No.
No. This little B, where does it get to go?
It goes to the 2 boxes below it.
2 boxes below it. So it goes here. Does it get to go here?
Yes.
This B, where does it get to go?
There's 2 boxes beside
Over.
This box?
Yeah.
Does it get to go to this box?
No.
No. Does it get to go to this box?
Yeah.
Yes. This one gets to go to these last 2, right?
Yes.
So, the 3 possible genotypes that your offspring could have are going to be what? Or 2. You got 2 types.
Blonde.
Big B, little b. And what's the other one?
Little B, little B. Undertaking.
No. So, 2 boxes have big B, little b. 2 out of 4 is going to be what percent? 50%. You've got 2 out of 4 boxes have little b. What percent is that going to be? 50%. So parent 1 and parent 2, their offspring has a 50% chance of being heterozygous for brown hair, and then a 50-50 chance for being homozygous recessive for blonde hair. Does that make sense?
Yeah.
Did we?
So, example 1. No, you all do not have to write this,
Oh, cool.
but you all will need to do the Punnett squares in your notebook. So, you're going to set up your Punnett square, right? Big pretty square. How many sections?
4.
4. So we are going to calculate the probability from an offspring of 2 parent cats. One is going to be homozygous dominant for a long tail. Which genotypes are going to be what? 2 big T's. So parent 1, 2 big T's. That's parent 1. Parent 2 is homozygous recessive, so they're going to be what, Colin? 2 little T's. So your 2 big T's for parent 1 are up here. 2 little T's are down here. Create a Punnett square to predict the possible combinations for the offspring. So, what are we going to have in box 1 here? You're going to have a big T and then a what? Little T. This box, what are you going to have?
Big T, little T.
Big T, little T. This box.
Big T, little T.
This box.
Big T, little T.
So, what is the probability that this cat has a homozygous dominant tail? Long tail.
100%.
Homozygous. Homozygous means what? So if it is homozygous dominant, what is the genotype going to look like? 2 capital T's. Oh.
There is none.
Homozygous dominant. So what's the percent chance that it will be homozygous dominant for a long tail?
0.
Homozygous. 0%. If you need help, you can raise your hand. You are going to log on to IXL and complete R5, complete and interpret Punnett squares. You are going to do that to a minimum of 80% mastery. So, if you have questions, raise your hand. You are to be doing this individually. Should there be talking?
No.
Okay, you all have the rest of class to work on this. Only thing I should do should be that clicking of my boots. I'm going to go ahead and post these Google Slides on the Google Classroom.